Hi everyone, welcome to another video in this playlist looking at 10 key topics needed for our grade C in our Edexcel GCSE exam. So we've identified 10 topics that we think always come up and are likely to bank you some easy marks in your search for that elusive grade C. This video is looking specifically at the fourth topic on our list, which is area, and we're looking particularly at area of some of the basic shapes, not more of some of the advanced shapes. And so we're going to look at a couple of practice questions here. Now, before we start and we look at the questions, I would tell you that there's only really 3 shapes that you need to remember the formulae for when you're trying to find area for your GCSE. The first is a rectangle, and I'm just going to draw one out here, really scruffily I'm afraid. And to find the area of a rectangle, it's the base and the height dimensions, so this length here and this length here, sometimes they're called length and width or base and height, and they're multiplied together. So the area of a rectangle is the base multiplied by the height. And that's a really useful formula because it also incorporates other shapes like squares, parallelograms, or actually what are known as compound shapes, where we can break them up into combinations of rectangles and other things. The second shape that you do need to remember the formula for is a triangle. And the formula for the area of a triangle, again, is the base and the height. And I need to be really careful here and point out to you that you remember it's the horizontal base and the vertical height. So it's the ones that meet perpendicular to each other, the ones that form a right angle. Okay, it's never this slopey side here. That would be used for maybe a surface area question, possibly a Pythagoras question. But in terms of finding area of a triangle, it's the flat base, the horizontal base, and it's multiplied by the height that's going perpendicular to it at a right angle to it. So area for a triangle is base times height. But you're probably going to scratch your head there and go, well, hold on, how could it be the same as a rectangle? They don't even look like the same shapes. Well, actually we use the kind of rule for a rectangle to form the rule for a triangle. If I did base times height, we've just talked about how that's the area of a rectangle, so I'm technically finding this space here as well. I don't want this space, I only want this portion here, and not only does it roughly look like it, but it's exactly half of the surrounding rectangle. So for a triangle, it's base times height, and then we half our answer. Okay. The other one you do need to remember is for the area of a circle, and I always teach my students to remember this kind of using a little kind of rhyme, if you like. Cherry pie is delicious, cherry pie is delicious, and I'll come back to that formula in a minute. Apple pies are too. And we've got 2 rules there, and I'll talk about them separately. A stands for area, so the area of a circle is pi times r squared, and if you look that up on most revision sites or in a revision book or possibly in your exercise book, you've probably written it as pi r squared. I like to write the times sign in there just to kind of remind myself in my head to use bid maths properly. It's only the r that gets squared, it's not the pi that gets squared as well. So we do r squared and then we times it by pi. At this point you're probably asking the relevant question, well, what is this r that you're talking about? R stands for radius. And the radius is this measurement here. It's halfway across the circle. It's from the centre of the circle to the edge. The formula that I've written there that we're not going to talk about in this video, but is important in terms of talking about how to find information around circles, is this cherry pie is delicious, or this C value. And this C value stands for the circumference. And the circumference of a circle is a fancy special word for the perimeter of a circle, all the way around the edge of a circle. Okay, and again there's another letter here that we haven't talked about yet, D, and D stands for diameter, and the diameter is all the way across the circle passing through the centre. That's really important. So it's like 2 radii, okay, or other way around, a radius is half the diameter. There is one other that you do need to know for finding area, and that's the area of a trapezium, and I'm going to write that one down above this label here. It says diagram not drawn accurately. Trapeziums often look like this, but they can come in a variety of forms as long as one pair of sides is parallel. And you will also find that you'll be given, or you'll see the following dimensions for this one. You'll know the length of this side here, you'll know the length of this side here, and you'll also be given the vertical height, not the slope side, but the vertical, the one that's perpendicular to these 2 parallel sides here. And the rule is A plus B halved. And what we're doing there is we're adding this base and we're adding this base and we're halving them to find the average base. And then whatever that calculation is, we times it by the height. So very similar to the the formula for the rectangle. It's just obviously it's not a rectangle. These two are different lengths, so we have to find the average of them first. Now, why have I written that in a different colour, and why didn't I mention it in terms of there's 3 key rules you need to remember for the exam? Well, the good news for this one is, as long as you remember what I've just said in terms of how to use the rule's actually given on the formula page in the exam, so you don't need to remember that, you just need to remember how to use it. So let's apply some of those rules to this shape here we've got on the left. It says the diagram shows a shape, work out the area. Now, what you need to understand is I've just told you all the shapes that you need to be able to find the area for. So if you encounter a shape like this that isn't one of those, it's what's known as a compound shape. It's been made from at least some of them. So what we need to do is chop it up into some of those shapes and then find them individually. The most logical place to do this one, and this will come through the more you practice with your experience, is to chop it there. And I've therefore chopped it into a rectangle here and a triangle here. So I've got 2 individual shapes that will come together to make the overall shape. So I'm going to label this one shape 1 and I'm going to label this one shape 2. No preference there, you could have done them the other way round, it doesn't really make any difference, and I'm going to find them individually. So shape 1 is the rectangle here, and the rule for a rectangle over here is the base times the height. So in this example 8 times by 9. So shape 1 is base times height, 8 times 9, so 72 centimetres squared. So I've got that portion there done. Shape number 2 is the triangle here, and what we need for the triangle, looking at the rule over here, we need the base, we need the height, the two that kind of form the right angle, they're perpendicular to each other. We're going to times them together and we're going to half it. So we don't want this length here, we do want this length here, and we do want this length here, and then the bad news unfortunately is neither of them are given to us in the question. But they're not there to stitch us up or trick us. There must be a method of being able to find these, so let's have a look and try and be a bit crafty with this question. So I know the overall height of the shape is 9, because it goes from these 2 points here. I know this portion of the shape is 4, so if I carried on going to make the total of 9, this portion here would have to be the difference between the numbers. So the base of my triangle, if I kind of orientated it that way, is going to be 5 centimetres. Going along here, I've got the length of the whole shape being 20. Travelling down here, this portion is 8, so the remainder here, this distance here, because if this is 8, I can transfer that up and that bit's going to be 8 as well. If this is all 20 and that bit's 8, then this bit here is going to have to be 12. So I've got my 2 key dimensions there. I've got the base and I've got the height that are perpendicular to each other, and the rule is base times height. So 12 multiplied by 5, which is 60, and then halved. So that's going to give me a value of 30 centimetres squared. And then don't forget, and it's a common mistake we see every year, to add these 2 spaces together. So this space here is 72, this space here is 30. Together, they make the overall area of the compound shape, so 102 centimetres squared. Let's have another practice at that. We've got another question down here, a funny looking shape here that's been made from some of those shapes that we've already talked about. So we've got on the bottom here, I suppose if we're going to, let's call this a muffin, we've got the case down here, and that's a trapezium. So we've got a trapezium here, and we talked about how to find the area of a trapezium, and we know that it's on the formula page. And then up here, the muffin top if you like, the kind of sponge bit up here, we've got a semicircle. And we talked about how to find the area of a circle, and a semicircle is just half of that. So we've got our 2 shapes there. Doesn't really matter what order we do them in, so let's call this number 1 the semicircle, let's call this number 2 the trapezium, let's work them out individually and add them together. So area of a circle is pi times r squared, so a semicircle is going to be half of that. So I'm going to do pi times r squared, and then I'm going to half my answer. So the only thing we need to find, because pi is a constant, that's a value on our calculator, divided by 2 is a constant, so I just need to find this value here for r. R, we remember said, stands for radius, which is halfway across the circle, so this length here. If all the way across, known as diameter, is 20, then r, halfway across, is going to be 10. So my rule there is pi times 10 squared divided by 2. Pi is about 3.14, 10 squared is about 100, so 3.14 times 100 is roughly 314, although you'd be calculating this accurately on a calculator. And then I half that answer, so we're looking at roughly 157 centimetres squared for the semicircle. But I must make a point here, and I'm not obeying my own rules, so slap on the wrists. Do not round at this stage here, only round when you get to the final answer in a minute, which will be when we've calculated the trapezium as well. So let's move on to the trapezium. The rule is A plus b, although if you put them the other way around it makes absolutely no difference, it just means the length of the two parallel sides. So I'm going to do 12 plus 20, and then I half that, I divide that by 2 to find the average between the two numbers. So I've got 12 plus 20 is 32, half 32 is 16, and then I multiply that by the vertical height, the ones at the perpendicular to the base, and that's 10, and that's going to give me an area of 160 centimetres squared. If you forget that the formula for the trapezium's there, or you forget what A, B and H are, or you get a little bit confused, there's no reason why you couldn't treat this shape like we did in the shape for question 1 and make it a compound shape. So you could, for example, it's a bit more work but it's simpler I suppose, you could chop it there and you could chop it there, and you could have a triangle and another triangle and a rectangle. So you could chop it into compound shapes themselves and calculate them individually and add them together, but I've used the area of trapezium formula, which is on the exam page because I've remembered how to use it. Don't forget, final stage, it's a compound shape, so we need to add those two areas together. So we've got 160 plus 157, so that's going to give us what, 317 centimetres squared as our final answer. Just remember those formulae, guys, and you'll be fine.